Antioxidants, anti-inflammatory substances can prevent free radical production. Dr. Guarneri showed us this morning how dietary changes with less saturated fat, using various spices like curcumin, reducing alcohol consumption, can reduce the production of free radicals, can reduce inflammation, therefore reducing free radical production. Now, I'm going to show you kind of graphically how this works. We talked about these proteins modified by sugar called AGEs. They bind to receptors. This is a brain cell. They bind to these receptors called the receptor for the AGE. When they finally find their way, they come in and they bind to that receptor, and that actually affects the nucleus of that neuron, which unwinds the DNA and produces something called COX-2 enzyme. You've all heard of COX-2 enzyme. You've heard of COX-2 inhibitors, things like Vioxx and Celerex. This is why they work, because they block this COX-2 enzyme, which is involved in creating inflammatory chemicals. Well, you can inhibit the COX-2 enzyme by using something called N-acetylcysteine, which is a very difficult to come by product. It's found in about every health food store in the United States, NAC. So, how does NAC work? If you measure how much COX-2 is turned on in the presence of NAC, it's dramatically reduced. So really, NAC is nature's COX-2 inhibitor. In the presence of NAC in the milieu, when there's a binding of that receptor, then there's much less production of COX-2. This is why NAC is a critical part of our program to preserve the brain and to even enhance brain function in people who already have things like Alzheimer's. Study actually published in the journal Neurology. The group taking NAC had outcomes favored on almost every subpart of that test that they did. I take NAC every day, and it's not that I have Alzheimer's, or at least I don't think I do. But the point is, this is how you preserve brain function. It's a powerful antioxidant and reduces activation of the COX-2 enzyme. I was recently traveling, making slides. I make a lot of these slides when I travel. And I was reading the Journal of the American Medical Association. And many of you have seen the Journal of the American Medical Association. I had it in the seat back pocket in front of me, and the man said to me, can I take a look at your JAMA, Journal of the American Medical Association? And I thought, okay, whatever. And I said, isn't it great that I wasn't reading the proceedings of the National Academy of Sciences, because then he would have said, can I take a look at your PNAS? I'm not sure how I would have responded. They didn't turn the yellow light on for me, so I guess I can have one pass the muster. This study shows that, really quite simply, in laboratory animals, that if you induce diabetes by giving them a chemical that blocks the formation of insulin, that you immediately damage the part of the brain called the hippocampus, which is the center for memory. So diabetes has a direct effect specifically on the hippocampus, which is the memory center. Well, what is your risk if you're diabetic? If you're non-insulin dependent diabetic, your risk is already increased twofold. If you have diabetes and you're taking insulin, your risk of Alzheimer's disease is increased more than 400% because of your poor control of blood sugar. And these, at least type 1 diabetes may be preventable. We certainly know that type 2 diabetes is preventable. I mentioned glycohemoglobin. It's a test that all diabetics get, measures their blood sugar. As that number increases, look at the degree of brain wasting over the years. So the higher your glycohemoglobin, the more you've lost brain cells. We're going to learn towards the end of my presentation today that you can actually regrow brain cells. Can you imagine? I remember in college they used to tell us that when you drank a beer, you lost 10,000 brain cells. Remember they used to tell you that? And whatever else others were doing in those years, I'm sure. If that were the case, and you couldn't regrow brain cells, I'm not sure I'd be standing here giving a lecture right now, but nonetheless. If your insulin level is up, which is a sort of a pre-diabetic condition when your pancreas is starting to work overtime to put that blood sugar away, it increases the availability of the production in the brain of a protein, which we're going to focus on, and this will be on the quiz, called beta amyloid. Now, beta amyloid is sort of the protein of Alzheimer's. It accumulates in the brain. We used to think it was just sort of the scar or the detritus of dead neurons, but we now know it's very active metabolically. it in and of itself increases inflammation. So amyloid protein is very important in, come on, you can do it, in Alzheimer's. That's the protein involved. This study shows us that as our insulin levels climb because we're eating too much sugar and not getting adequate exercise, we increase the production in the brain of this chemical called amyloid. If you measure, in fact, the production of amyloid in the brain versus various inflammatory mediators, you find that the higher the level of inflammation in the brain, the more amyloid there is, and this is brought on by elevation of insulin. And it happens very quickly. That last slide that I demonstrated was people who received insulin intravenously, and their amyloid production went up immediately. So it's that dessert that you have. So this is what amyloid protein looks like. Not sure why I included it, but it just gives it some physical sort of representation. Now, you can actually there's something called the Pittsburgh compound, which was just developed, obviously in Pittsburgh, that allows research scientists to measure, to visualize amyloid protein in the living person. It used to be, not long ago, 2-3 years ago, if you wanted to determine amyloid in the brain, it was actually post-mortem. You can now measure amyloid protein in the brain. On the left, and these are what we call SPECT scans here that measure metabolic activity. Here's a standard MRI of, I think, normal on the top and then Alzheimer's on the bottom. And then here we see a significant increase in this amyloid protein. So it correlates dramatically with Alzheimer's disease. Now, we have at our clinic now installed a very, very high-tech machine for looking at the function of the human brain. And I'm going to, this is really one of the earliest places where people are going to get to see this. I'm going to show you.
Electroencephalograph. It records the electroactivity of the brain, and this way we can tell whether the brain is working properly, and if not, we can get some idea of what's wrong with it.
I don't want to be accused of not being on the cutting edge. I want to just take a moment and tie back into diabetes, but I want to talk about a little bit of genetics. I was on, as mentioned, this Fox News program. It was quite an experience. It was back in the second presidential election, Bush running for a second term. And I was doing an uplink from Tampa where you go into a studio, they put the feed in your ear, electrical feed, they put new food in your ear. But and then they ask you questions while you're being interviewed on Fox News. Well, somehow the technician got his wires crossed, and I was hearing President Bush campaigning in my ear, trying to answer questions that this guy was mouthing to me and trying to read his lips. It was, you talk about stress hormones being produced and how effective on your heart. That probably took a couple years off my life anyway. But nonetheless, the interviewer said, well, doctor, isn't it true that it's just a genetic situation? If my parents had it, I'm going to get it. There's really not anything I can do about it. And I said, with all due respect, and I explained to him, we talk about genes as being these things that are locked in a glass case where information comes from genes and dictates what our life will be like and what our physiology will be like. We now know that is absolutely wrong, that genes are influenced every moment in terms of what they do by environmental issues, like attending a lecture, like eating a meal, like getting sleep, like feeling joyful or feeling sad. Sadness changes your genetic expression. Joy turns on genes that are good for you, creates chemicals in the brain like serotonin. Just sitting here right now, my lecture is turning on and turning off hundreds of genes in your body right now. Well, the main gene that we like to talk about with reference to Alzheimer's disease is called the APOE gene, apolipoprotein E. You have three possibilities. You can have the 2, 3, or the 4. If you happen to carry the APOE4 gene, it takes away from your antioxidant protection of your brain. And therefore, you would expect that your risk of Alzheimer's is increased if your APO gene 4 positive, and indeed it is. Anywhere from 8 times to 14 times. So it's something that you should have done. It's a test that any doctor can do. Please, doctor, let me know my APOE status. If you have APOE4 gene, you have to increase your antioxidant protection.